Hello there. Today I will be discussing all about chemical reactions and equations. Acids, bases and salts. A process in which one or more chemical substances react with other chemical substance and convert it to one or more different substances is known as chemical reaction. A chemical reaction is a process that leads to the transformation of one set of chemical substances to another. A process in which new substances with new properties are formed. Examples: hydrogen plus oxygen is equal to water. Potassium plus selenium is potassium selenide. There are two parts of a chemical reactions, which are reactants and product. Reactants, substances that are broken down by the chemical change. Products, substances created by the chemical change. The simplest form of description of a chemical reaction in a shorter form is by writing it in the form of an equation. For example, magnesium plus oxygen is equal to magnesium oxide. Mg plus O2 equals MgO. The reactants are written on the left side and product is written on the right side. Which of the substances magnesium and oxygen are known as reactants, and the result of reaction, that is magnesium oxide, is known as product. An arrow is placed between them to show direction of reaction. The number of atoms of each element always remains same, before and after the chemical reaction. Characteristic of chemical equations. The equation must represent known facts, and must contain the correct formulas for the reactants and products. The law of conservation of mass must be satisfied. Showing phase in a chemical equation. Solid phase, S. The substance is relatively rigid and has a definite volume and shape. Liquid phase, L. The substance has a definite volume, but is able to change shape by flowing. Gaseous phase, G. The substance has no definite volume or shape, and it shows little response to gravity. Skeletal equations are those equations which shows the reactant and product to formed without balancing them. Here are examples. Mg plus O2 equals MgO, which is magnesium peroxide, and H plus O equals H2O, water. It is also known as unbalanced equation. The equation needs to be balanced so that it follows the law of conservation of mass. A balanced chemical equation occurs when the number of the different atoms of elements in the reactant side is equal to that of the product side. Here are examples on how to balance an equation. This is a reaction between methane, CH4, and oxygen, O2, producing carbon dioxide, CO2, and water, H2O. The reaction shown is a combustion reaction. A compound reacts with oxygen and produces carbon dioxide and water. The technique is to balance the carbon, C, atoms first, then the hydrogen, H, atoms, and then the oxygen, O, atoms. In this case, the carbon atoms are already balanced. So now we look at the hydrogen. There are 4 hydrogen atoms on the reactant side and 2 hydrogen atoms on the product side. To balance them, we put a coefficient of 2 in front of H2O. The hydrogen atoms are now balanced. Due to the coefficient 2 in front of H2O, there are a total of 4 oxygen atoms on the product side. To balance the oxygen atoms on both sides, we put a coefficient of 2 in front of O2. The chemical equation is now balanced. Here we have sodium plus chlorine, which gives sodium chloride. Let's check if this equation is balanced. Analyze the table carefully. So is this equation balanced? No, as you can see here, the chlorine atoms are not balanced. The trick to balancing is to start the element that's not balanced. Here you can see chlorine is not balanced, so to balance it we need to multiply it by 2. So put 2 here in right side, which is the product. Now we have balanced chlorine both sides. But now we have disturbed sodium. Sodium becomes 2. Worry not. In order to balance the equation, we are going to multiply by 2 here in the left side so that sodium will also be balanced. Now we have a perfectly balanced equation. What is change? It is the act of altering a substance. An event, not a trait. Before condition and after condition. Can be physical or chemical. Physical change does not alter the chemical composition or identity of the substance, only the form. It is a type of change where the physical properties of matter change. A change of state of matter, change in color, odor, solubility, etc. All are examples of physical change. Here are some examples of physical change: melting ice, change in state or phase, freezing Kool-Aid, tearing paper, boiling water, change in state or phase, making a mixture, water plus sugar. Chemical changes does alter the chemical composition or identity of a substance and makes new substances. A chemical change happens when one chemical substance is transformed into one or more different substances, such as when iron becomes rust. A chemical change is also called a chemical reaction. Examples of chemical change: burning paper, digesting food, rotting, and iron reacting with oxygen gas. Indications of chemical reactions: change in color, change in state, evolution of gas, change in temperature, and formation of precipitate. Following are the major types of chemical reaction: combination reaction, decomposition reaction, displacement reaction. When two or more substances, that is elements or compounds, react to form a single product, such reaction is known as combination reaction. For example, as illustrated in the above reaction, calcium oxide and water reacted, or combined, to form a single product, known as calcium hydroxide. The chemical reaction in which heat is also released along with the formation of product is known as exothermic chemical reactions. Exothermic and endothermic reactions. Endothermic process, a change, for example a chemical reaction, that requires, or absorbs, heat. Photosynthesis is an endothermic reaction, requires energy input from sun, while exothermic is process, a change, for example a chemical reaction, that releases heat. Burning fossil fuels is an exothermic reaction. The difference between endothermic reaction and exothermic reaction. Endothermic reaction. A reaction that the system absorbs energy from its surrounding in the form of heat, while exothermic reaction releases energy from the system in the form of heat. When it comes to energy. Endothermic reaction. The surrounding energy in the form of heat is absorbed by the reaction, for example a melting ice, evaporation, cooking, gas molecules, photosynthesis are a few examples. While the energy in exothermic reaction is being released from the system to its environment. Energy is released as heat, electricity, light or sound. For example rusting iron setting, chemical bonds, explosions, nuclear fission are a few examples. Decomposition reaction. The reaction, in which a single reactant breaks down into simpler products, is known as a decomposition reaction. In the above given reaction, ferrous sulfate crystals, which is FeSO4, 7H2O, when heated, it loses water and the color of the crystals changes. Finally, it decomposes into ferric oxide, Fe2O3, sulfur dioxide, SO2, and sulfur trioxide, SO3. The reaction, in which an element displaces or removes another element, is known as displacement reaction. In the above given reaction, iron displaced copper from copper sulfate solution and forms iron sulfate. If a substance gains oxygen during a reaction, it is known as oxidation. On the other hand, in a reaction, if a substance loses oxygen, it is known as reduction. In the above given reaction, the copper oxide loses oxygen and hence reduced, that is reduction. On the other hand, hydrogen gains oxygen and hence oxidized, that is oxidation. A metal is attacked by substances found in the immediate environment, such as moisture, acids, etc. It is known as corrosion. For example, the black coating on silver, the green coating on copper, etc. When fats and oils are getting oxidized, the process is known as rancidity. Their smell, taste, color, etc. also change. Likewise, it made food unsafe for consumption. Rancidity can be classified into two major types, oxidative rancidity and hydrolytic rancidity. A reaction that causes oxygen damage to a food substance is called oxidative rancidity. And hydrolytic rancidity generally causes an unpleasant odor. This is due to the release of free fatty acids from glycerides. Now let's talk about acid, base and salts. We taste food sour and bitter. It is only because of presence of acids and bases respectively. Acid is a chemical substance, usually a liquid, which contains hydrogen and can react with other substances to form salts. Some acids burn or dissolve other substances that they come into contact with. Base is a substance that can neutralize the acid by reacting with hydrogen ions. Most bases are minerals that react with acids to form water and salts. Bases include the oxides, hydroxides and carbonates of metals. The word salt is a general chemical term that refers to ionic compounds formed when an acid reacts with a base. Salt is a mineral composed primarily of sodium chloride, a chemical compound belonging to the larger class of salts. Salt in the form of a natural crystalline mineral is known as rock salt or halite. Litmus, which is extracted from lichen, has purple color, see the image given below, but the condition is when it is neither acidic nor basic, that is neutral. Litmus basically is a plant belongs to Thylophyta, and in chemical experiment, it is commonly used as an indicator. The substances, which odor changes in acidic or basic media, are known as olfactory indicators. What are olfactory indicators? Here are certain substances whose odor, smell, changes in acidic or basic solutions. These substances are called olfactory indicators. The olfactory indicators have a characteristic odor. This odor in olfactory indicators is changed in acidic or basic solution and helps us in detecting whether a given sample solution is acidic or basic in nature. Acid or base in a water solution. The hydrogen ions in HCl are produced because of the presence of water. Secondly, the separation of H plus ion from the HCl molecules cannot be done in the absence of water. The chemical formula is illustrated below. Furthermore, hydrogen ions cannot exist alone, but they can exist in presence of water molecules. Therefore, hydrogen ions are shown as H+, Aq, or hydronium ion, H3O+. The chemical formula is the bases which are soluble in water are known as alkalis. But all bases are not soluble in water. If water is added to a concentrated acid, then the heat is generated. Mixing an acid or base with the water results into decrease in the concentration of ions, that is H3O+/OH per unit volume, and the process is known as dilution. A scale, used in measuring the hydrogen ion concentration in a solution, is known as pH scale. The P in pH stands for potens. It is a German term, which means power. pH value is taken simply as a number, which indicates the acidic or basic nature of a solution. So, if the concentration of hydronium ion is higher, then the value of pH would be lower. The value of pH scale ranges between 0 and 14. So, if pH value is measured 0, it means it is very acidic, and if it is 14, then it means it very alkaline. The neutral value of pH scale is 7. On a pH scale, Values less than 7 represent an acidic solution and values greater than 7 represent a basic solution. Likewise, the strength of acids and bases substance mainly depends on the number of H+ ions and OH ions produced, respectively. The following image roughly illustrates variations in color, the pH value of some of the common substances. The importance of pH in everyday life. The pH value of a human body ranges between 7.0 and 7.8. The stomach of a human body produces hydrochloric acid that helps in the digestion of food. Surprisingly, it does not harm the stomach anyway. However, when the stomach produces too much acid, known as indigestion, it causes pain and irritation. To get relief from this pain, doctors suggest the use of bases known as antacids. These antacids neutralize and control the increased amount of acid. The teeth, which are made up of calcium phosphate, is the hardest substance in the body. However, when the pH in the mouth decreases below 5.5, it corrodes the teeth. The salt, normally, is formed by the combination of hydrochloric acid and sodium hydroxide solution. And the combination is known as sodium chloride. When the pH value of rainwater is measured as less than 5.6, it is known as acid rain. When acid rain flows into the rivers, then it also lowers the pH of the river water. The acidic river water is threat for the survival of aquatic life. The baking soda is commonly used in the kitchen in order to cook tasty, crispy food items. It also cooks some food items faster. The chemical name of baking soda is sodium hydrogen carbonate and formula is now HCO3. Recrystallization of sodium carbonate results into washing soda. The chemical formula of washing soda is Na2CO3, 10H2O. Washing soda is commonly used in glass, soap, and paper industries. Plaster of Paris is a white powder that doctors use as plaster for supporting fractured bones. The chemical name of plaster of Paris is calcium sulfate hemihydrate. The chemical formula is 2Ca SO4H2O. Thank you for watching. See you again.